Hello, Math 200, section 5.2, normal distributions, finding probabilities. When a random variable x is normally distributed, you can find the probability that x will lie in an interval by calculating the area under the normal curve for the interval. So this is kind of what we got into a little bit in this last section, that the area under the curve corresponds to the probabilities of being those particular values that we're talking about on the curve. So to find the area under any normal curve, first convert the upper and lower bounds to the interval to z-scores. You actually don't have to do that. You would have to do that if you didn't have a calculator. If you had to use tables, you would have to convert whatever value you're talking about for any normal distribution to a z-score, and then use the standard normal table in the back of the book or that you would find somewhere. But because we have the TI-84 calculator, there's really no reason to have to do that, because the calculator will do that for us without that kind of conversion. So let's just get on to the examples and we'll show you how to do it in the calculator. A survey indicates that people keep their cell phone an average of 1.5 years before buying a new one. The standard deviation is 0.25 years. A cell phone user is selected at random. Find the probability that the user will keep his or her current phone for less than 1 year before buying a new one. Assume that the lengths of time people keep their phones are normally distributed and are represented by the variable x. So we're trying to find the probability that they keep their phone for less than a year. We got a mean of 1.5 and a standard deviation of 0.25. So we go to our calculator. We can go to second distributions, normal CDF. We're talking about being less than a year. Less than a year. So the lower bound is going to be negative infinity, or negative 1, P99. The upper bound is going to be 1, because we're talking about being less than a year. So from negative infinity up to 1. The mean was 1.5. 1.5, we could put that in for the mean, and the standard deviation was 0.25. So we put 0.25 for the sigma and calculate it. The probability that a person keeps their phone for less than a year is 0.0228, or about a little more than 2%. Okay? A little more than 2% of cell phone users keep their phones for less than a year before buying a new one. We would consider that an unusual event, because anything that's less than 5% is unusual. And it's also unusual because it's more than 2 standard deviations away from the mean. All right. Next example. A survey indicates that for each trip to a supermarket, the shopper spends an average of 45 minutes with a standard deviation of 12 minutes in the store. The lengths of time spent in the store are normally distributed and are represented by the variable x. So the average shopper spends about 45 minutes, but the standard deviation is 12 minutes. A shopper enters the store. Part A. Find the probability that the shopper will be in the store for each interval of time listed below. So part A, number 1 of part A, is between 24 and 54 minutes. We go to our calculator. Second distributions, normal CDF. Notice we're almost always using normal CDF. The only time we ever use normal PDF is when we're trying to graph the normal distribution function in the graphing calculator. But when we're doing these calculations, we're always using normal CDF. All right, we were talking about the shopper spend between 24 and 54 minutes. So the lower bound is 24. And the upper bound is 54. Simple. The mean, do you remember what it said? It was 45 minutes. The standard deviation was 12 minutes. And that's how we do it. Man, that's really simple, isn't it? I hope you enjoy how simple this is. 0.7333, or about 73% chance that the shopper will spend somewhere between 24 and 54 minutes in the store. All right, part B, or part 2 of part A. More than 39 minutes. What's the probability that the shopper spends more than 39 minutes? Again, go to normal CDF. This time we're talking about greater than 39. So if we're greater than 39, more than 39, that means the lower bound, the lowest we can be, is 39. And the upper bound, the highest we can be, is infinity, or 1e99. The mean and standard deviation are the same. So 0.06915, or about 69% chance of spending more than 39 minutes. Part B, interpret your answer when 200 shoppers are in the store. How many shoppers would you expect to be in the store for each of the interval of time listed below? So if you've got 200 shoppers, how many would spend between 24 and 54 minutes? Well, since you've got the percent or probability of that, just multiply the 200 total by the percent or probability of being between 24 and 54. So we would say 200 times this percent right here. 73% of the shoppers of those 200 shoppers are going to spend that much time. So 200 times 0.7333. And we get about 147 of those 200 shoppers will spend that amount of time. And then for the second one, it'll be 200 times 0.6915. So about 138 shoppers will spend that amount of time. I think it was above 39 minutes. 138 shoppers will be in there more than 39 minutes. That's how you do it. That's a good problem. Started off strong in 5.2. Okay. Triglycerides are a type of fat in the bloodstream. The mean triglyceride level in the United States is 134 milligrams per deciliter. Assume the triglyceride levels of the population of the United States are normally distributed with a standard deviation of 35 milligrams per deciliter. You randomly select a person from the United States. What is the probability that the person's triglyceride level is less than 80? Less than 80. All right, we got a mean, don't we? 134. We got a standard deviation, 35. And we got less than 80 is the thing we're trying to find. Second, distributions. Normal CDF. Since we're talking about being less than 80, what's the lowest we can be if we're less than 80? Negative 1e99. And the upper is 80. If we're less than 80, the highest we can be is 80. The mean in this case, wasn't 134? I can't remember. Let me look back. 134 and 35. 134 and 35. 134 for the mean. 35 for the standard deviation. And we got our answer, 0.0614. So about 6% would have triglycerides levels less than 80. Would we consider that unusual? It's kind of unusual, but you wouldn't say mathematically that it's quote unquote unusual, because to be unusual, it needs to be less than 5%. 5% or less. All right, that is it for section 5.2. Good luck on that assignment. I'll see you again in 5.3.